Hi, Math 30-1s. Just carrying on with trig functions and graphs. Today we're going to take a look at primary trig functions. So mostly we're going to discuss sine and cosine, what those graphs look like. I will give you a little bit of insight into what the tangent graph looks like at the end of the lesson, just so that you're aware of it. It's a little bit of a different beast, okay, when I compare it to sine and cosine. And yeah, I will discuss all the key characteristics, what you need to know about them, so that you are well equipped, okay, heading into the assignment portion of today's lesson and moving forward for future lessons. So, first definition for today is a periodic function. So it says a periodic function is a function whose graph repeats regularly over some interval of the domain, which are your x values. The length of the interval is called the period of the function. So the horizontal distance that it takes the graph to do one complete rotation is called the period length of the graph. And they will ask you that. They'll just say, what is the period of the function? And I'll show you how to find that on the graph. But you need to know what a periodic function is, and you need to know what the period of the function is. So those two terms we want to make sure we highlight, okay, and we understand. Next term that we want to understand is amplitude. So the amplitude of a periodic function is half the distance between the max and the min values. So real quick, and I'll tell you that now, when I do amplitude, we are going to take the max, which is the highest value the graph goes, subtract the minimum, the lowest value of the graph, and then divide by 2. Okay, so this formula is one that you are going to want to know and associate with amplitude. Max minus min over 2. If you don't want to write it there, that's fine. We get notes on it, okay, in a page or so. So we apply those terms now to these three examples. It says determine the period and amplitude for each of the following functions. So I'll start by doing the amplitude here. Okay, and like we said up above, amplitude is max minus min over 2. So the maximum that this graph goes, the highest, is 10. Minus the minimum, this would be the lowest that the graph goes, which is negative 10. So it's going to be 10 minus negative 10. Okay, and then I have to divide by 2. So 10 minus negative 10 is 20. 20 divided by 2 is 10. Okay, so the amplitude for this graph, this periodic function, is 10. Now, the period length, okay, I'm going to show you how to do this a couple ways, because sometimes they don't give you a full picture of the full graph. They only give you a partial one, so I'm going to give you about 3 different ways here to find the period length of a graph. Now, hopefully, we can always look right on the x-axis, okay, and see the horizontal distance it takes through the graph to do one complete cycle. So from there to there is one complete cycle for this graph, okay? It's at this point that the graph now starts to repeat, okay? So there's the same shape again. So I'm worried about that horizontal distance, okay? So which is from here to here, which would be 8, right? It takes 8 units. You can see that on the x-axis. So in this case, I would simply just say, okay, that the period, okay, is equal to 8 units. That's it. Okay, so pretty straightforward, but again, like I said, this one was very easy to see on the x-axis. So here's another way that we can find the period length for a graph. I can also go from a maximum point to another maximum point. Okay, find that same maximum point when it occurs again. This maximum point here occurs at 2. This maximum point is occurring at 10. Well, the horizontal distance from 2 to 10 is, guess what? Well, it's also 8, isn't it? So same answer we got when I looked and tried to read along the x-axis. Now the third way we can do this, okay, is the following. And this comes with usually trickier questions when they don't give you a picture of the full graph. If I know from what I just said that from maximum to minimum, or sorry, max to max gave me the period length, okay, of 8 units, okay, and these graphs are symmetrical because they keep repeating over and over again, that would therefore mean that the max to the minimum, so there's the minimum, okay, would be half of the period length, wouldn't it? So I'm going 2 to 6, which is 4. Well, that's half of the period length, okay? Because then I know from here to here would be another 4, and 4 and 4 is 8. So if you can see from a max to a max or a min to a min, that's great. That's your full period length. But if you have to go from a maximum to a minimum, that's going to be half of your period length, so you have to double it, to get the full period length for your periodic function. Okay, same idea here with this next graph. So first thing we want to do is we want to do the amplitude, okay, or calculate the amplitude. So the max for this graph would be here, okay, which is at 6. I'm going to subtract the minimum value, which appears to be right here at -2. So 6 minus -2, now I have to divide by 2, take the average of those values. So that is going to be 8 divided by 2, which is a value of 4. So the amplitude for this periodic function is 4. Okay, now to try and calculate the period length. So how long it takes this graph to complete one full cycle. So again, if I start here, okay, that's fine, okay, and you try and go there, you follow the graph until it starts to repeat at that same point. Not here, okay, because at this point I'm going, yeah, sorry, it is right there, okay, because that's where the graph starts to go down again, okay? So you can see that distance would be from -1 to 5, which would be 6 units, okay? Or if you don't like that, okay, you could find a point, try and find a point on the x-axis, like right here, and see where that point occurs again. So sometimes those points are really easy to see, and there you go. So again, I'm going from 1 to 7. So 1 to 7, that's also 6 units. Okay, if you don't like that, then we go from this maximum to the maximum that occurs next, which is at the same point. This one is at 3, this one is at 9. That's also 6 units. And if you don't like that, then I could go from the maximum to the minimum and then double it. So the max is at 3, the min's at 6. So 3 to 6 is 3. And then you would double that, wouldn't you? So 3 and then another 3, okay? So any way you slice it, okay, for this periodic function, your period would be 6 units. Okay, last one for this little section here. Again, I first want to calculate the amplitude. So that's my max minus min over 2. So the maximum height of this graph is here at 6. I'm going to subtract the minimum, which is here at a level of 2. So 6 minus, positive 2, and then divide by 2. So 6 minus 2 is 4. 4 divided by 2 is 2. Okay, so the amplitude is 2. Okay, the period length, again, find a point and then find that point again. So if I start here, right on the xy axis, I go right, up, to the right, down, okay, and then I would go right again, wouldn't I? So that's the end, okay, of where the next cycle of the graph would start. So up, down, there, okay, and then you would start again, okay, up, across, down, okay. So you can see each of those that I've covered there in a different color is 10 units long, isn't it, right? From here to here, okay, that's 10. So the period length, okay, the horizontal distance it takes for this graph to do one complete cycle is 10 units. Okay, so hopefully you understand period length and amplitude from those first little warm-up questions. Now, graphing the primary trig ratio. So again, remember the primary ratios are your sine, your cosine, and tangent, as they state below. To investigate the graphs of these functions, we're going to take a look at each graph. First off, just on a domain of 0 to 360, and then we'll extend that to an open domain, okay, which is all real numbers. Okay, so let's just take a look at that on the next page. Now, calculating sine of x where x is in degrees. So here's what I want to kind of take a look at. Now, I showed you this in one of the last lessons, okay? I'm just going to draw the graph of sine of x, okay, as it pertains to 0 to 360 degrees. So, okay, remember this was 0 at the end here. This was 360. Okay, those were the x-intercepts. It also had one at 180 degrees. Okay, it hit its maximum at a value of 1. That was at 90 degrees. It hit its minimum value of -1, and that was at 270. Again, so what I've created there are the quadrants. Okay, quadrants 1, 2, 3, and 4. You can see that the graph is positive again in quadrants 1 and 2. It's above the x-axis, and negative in 3 and 4 where it's below the x-axis. So real simple, when I go to the chart that they want me to fill in, the sine of 0 degrees is 0. That's that point right there. I could go to the sine of 90 degrees. Okay, there's 90 degrees. Okay, the value there is 1. At 180, Okay, we're back at the x-axis at 0. At 270, the value on the graph is -1 down here. And again, 360, I'm back on the x-axis, so it is a value of 0. So those values are very easy to fill in. Now you can see between 0 and 90 degrees, the value of sine is going to be gradually increasing up to 1. Then from 90 to 180, still positive, but decreasing back to 0. Then it's going to decrease further down to -1 and then eventually increase back up to 360, okay, but still negative values, but getting closer to 0 again. So when I want to fill in this chart, all I have to make sure of is first, since I'm discussing degrees, and again, I know that because of the domain here, and even in the title, they say it's in degrees, I make sure that my mode for my calculator is in degree mode. Then I simply go, and you can even do the first one if you want, sine of 0, enter, it's 0. Then you're going to go sine of 30, enter, and you're going to get 0.5. Then you're going to go sine of 60, okay, so that's 0.87, because they said to 2 decimal places. Sine of 90 will be 1, okay, so then sine of 120, 0.87, and then sine of 150, okay, you'll see is 0.5. Okay, all those values were positive, weren't they? Now watch what happens. Sine of 210, negative 0.5. Sine of 240, negative 0.87. Sine of 300, negative 0.87. And then sine of 330 degrees, that's negative 0.5. So what you notice is that those values are repeated over and over again. Well, that's not just coincidence. It's because, for example, if I take a look at 30 degrees and 150, okay, remember that the reference angle for 150 degrees is 30 degrees, okay? And that's why the sine values are the same, because I can use the value of the reference angle to discuss the sine value of that big rotation angle, okay? And same thing when I go to 210, okay, the reference angle is 30 degrees again, but because of the quadrant I'm in, it's negative. Again, same thing for 330 degrees, the reference angle is 30 degrees, but again, because I'm in quadrant 4, okay, it is a negative value. So what they asked me to do is plot the points on the grid, but don't join the points. Well, this is what I can simply do, and you'll notice in B here, they give me window settings for X and they give me window settings for Y. So remember, the first ones are always the minimums. So X minimum would be negative 360 degrees. The second one in the X would be the X maximum, 540 degrees. And then, interesting, 30 is my scale. That means 30 degrees. So each tick on the X-axis is basically indicating 30 degrees. So watch how quickly I can graph this. Now, you can do it on your calculator and practice it. That's not a big deal, but we should be able to kind of graph this pretty well not using my calculator. So I start at 0 and 0 because that's where sine is. Sine at 0 degrees has a value of 0. At 90 degrees, I plot 1. 180, I'm back on the x-axis. At 270, back down here at -1. And then 360, okay, I'm back at a value of 0 on the x-axis. So they say don't join the points. I'm going to join them, and you'll see there's exactly what I drew above, right? Now that's one cycle of sine. So the period length for sine is 360 degrees, or if we were talking in radians, 2 pi radian. But you can see there's one complete cycle of sine. So when they ask you what the period length of sine is and cosine, okay, they're both going to be 360 degrees. So what would happen is, because it is a periodic function, it now just repeats, okay? So again, at 360, you could kind of treat that like your starting point again. At 90 degrees later, you'd be back up at 1. 90 degrees later, you'd be back down there on the x-axis. So I just extend the graph, and you can see it just keeps going. And I can do the same thing going back the other direction. So here at 0, 0, 90 degrees later, I would have been at -1. 90 degrees before that, I would have been on the x-axis. 90 degrees before that at a maximum value of 1. And 90 degrees before that, back on the x-axis. So you can see I've kind of got these 2 full cycles of sine and then a half cycle at the end. But that's what this graph of sine of x would look like between -360 degrees and 540 degrees. And that's what you'll see on your calculator, okay, when you graph it under y equals sine of x with those window settings. So they say on the grid now copy and complete the graph from -360 to 540. Well, that's what I just did, okay? Now, sine of x is actually a periodic function whose graph continues indefinitely to the left and to the right. So the reason that my graph stopped where it did up there is because of the domain restrictions or the window settings that they gave me. But sine, just like cosine, just like tangent, carry on forever in both the negative and positive directions on the x-axis. Okay, so we normally talk about sine and cosine and tangent on a domain of real numbers. Okay, and that's what we're going to talk about below here. So state the following for sine of x, where x is defined on the set of real numbers. Okay, like so. That's what they mean by defined on a set of real numbers. So the domain, well, there's the answer to my domain. X is an element of the real numbers. Now the range, sine and cosine never go any higher or lower than 1 or negative 1. So my y values, therefore, are always going to be between negative 1 and 1. Okay, what's the amplitude? Well, remember, amplitude is max minus min over 2. So the max is 1, the min is negative 1. So 1 minus negative 1 is 2 divided by 2 is 1. So the amplitude for those graphs is 1. The period length, 360 degrees, right? The length of time horizontally or distance horizontally it takes for the graph to complete one full cycle. Now the x-intercepts, okay, these are interesting. How often do they occur? Well, if you take a look at your graph, okay, the x-intercepts occur here at 0, then at 180, then at 360, then at 540. They're occurring every 180 degrees in both directions. So every 180 degrees I hit the x-axis. So therefore, I can say the x-intercepts are at every 180 degrees n, where n is a member of the integers. Now that expression seems confusing, but all that I'm saying is it's occurring every 180 degrees, and I can put any value in for n as long as it is a positive or negative whole number. Okay, I will land on an x-intercept. So there's an expression for what the x-intercepts are. You can't list them all because there's an infinite number of them in both directions, positive and negative. And the y-intercept, there's only one y-intercept. That's at the origin, 0. So you only have one y-intercept, which is at 0. Now on the next page, it says, a student was asked to reproduce the graph in exploration B, which is just the graph of sine of x, but they want it in radian mode. So write down the graphing calculator window that the student would use. So the window would look like this. For the x values, okay, because now I'm in radian mode, well, the first one they had was negative 360 degrees. That's negative 2 pi in radian. The x maximum was 540 degrees. Well, 540 degrees is 3 pi. And the scale was 30 degrees. 30 degrees in radians is pi over 6, 180 divided by 6. So there are the window settings I would have to enter into my calculator after I've put my calculator in radian mode. Now the y's are interesting. The y's are unaffected, okay? The reason is that the y scale is just measuring height of the graph. I'm only concerned about changing the x values or window settings for my x. So the y's, I can use the exact same values we had for the previous question, negative 1.2, 1.2, and 0.2, okay? So those don't change, okay? It is just the x values that I need to change when I go between radian and degree mode. Then sketch the graph of sine of x between 0 and 2 pi. So that's just one cycle of pi, isn't it? Because we know that's how long it takes it to graph. So if I graph that in radian mode, okay, it has to be in radian mode. You'll see it looks exactly the same. This will be 0. This will be pi, and this will be 2 pi, known as 0, 180, and 360 in degrees. It'll hit its maximum value of 1 at 90 degrees, which in radians is pi over 2. It'll hit its minimum value of negative 1 at 270 degrees, which is 3 pi over 2. Okay, and there's what it looks like. Now, that's it for the lesson, but just as an aside, before you go and you start working on it, I want to show you again what the graph of cosine looks like, because you'll encounter that. So cosine looks the same as sine, but it starts at a max value of 1, okay, and does this. It's like the graph of sine has been shifted left and right. So this is y equals cos of x, okay? So it looks very similar in terms of the shape. It is a periodic function that repeats kind of up and down, ebb and flow, but it hits the x-axis in different places, but it does have a max of 1. It does have a minimum of negative 1 right here, and it hits that negative 1 value at pi, or 180 degrees. Its x-intercepts are here at 90 degrees, pi over 2 radian, okay, and here at 270 degrees, 3 pi over 2, and it's back up here at a max value, okay, of 1 at 360 degrees, or 2 pi. Okay, so that's what cosine looks like. Now tangent, okay, tangent is a very, very different looking graph, okay? So I'll do a little bit of an explanation here, and then I will let you go and work on the assignment. So this is what tangent looks like, okay? Then there's a vertical asymptote here. And then the next arm of tangent does this, and then again, I have a vertical asymptote, okay? And then I have another arm, okay, it goes like this. So that's what tangent looks like between 0 and 2 pi. These vertical asymptotes are occurring at 90 degrees, or pi over 2, and 270, 3 pi over 2. Okay, the x-intercepts are occurring at 0, okay, obviously, right here at 180, okay, and then again at 2 pi. Now the reason I have vertical asymptotes, okay, at 90 degrees and 270 is because of the unit circle. Okay, when I looked at the unit circle, which we learned the other day, at 90 degrees and 270, remember these points as coordinates were 0 and 1 and 0 and -1. Now tangent, okay, I should label that graph here, that this is y equals tan of x, okay, is that when I calculate tan of x, remember tan of x is always sine of x over cos of x, which is really you taking the y values and dividing by the x. So if I take the y value here and divide by the x, that's 1 over 0, which is undefined, giving me a vertical asymptote at 90 degrees. Same thing down here at 270. If I calculate the tangent, which is sine over cos, I'm going to be going -1 divided by 0. Anything divided by 0 is undefined. So at 270, I also have a vertical asymptote, okay? So a little bit difficult to understand tan of x in comparison to sine and cos. And the other thing with tangent of x, it doesn't have a max or a min value. These red arms that I drew, okay, continue to grow up kind of forever and down forever. They never reach those asymptotes. So there is no such thing as amplitude with tangent of x. Okay, so I did throw in a lot of extra information there at the end, but again, I think it's good that you see those graphs now so that when we start to discuss them in further detail moving forward, okay, you'll understand what I'm talking about. It won't be brand new to you, okay? So good luck with the assignment. And as always, if you have questions, don't be afraid to email me, get a hold of me. I'll get back to you as soon as I can with a pretty good explanation and some diagrams, some helpful hints, some calculations, which will push you in the right direction. So hopefully you guys are doing well.